This video is to discuss building Java programs, Chapter 12, which is about recursion, exercise 19, count binary. We're doing this on the Practice It website. So count binary is, it's somewhat misleading because you think, oh, this is all about binary. I've never seen anything about binary. And the truth is, this is exactly the same problem that the book describes for the traveling northeast situation. First, let me give you a brief explanation of how the count binary works, and then I'm going to show you in Eclipse how the traveling northeast problem is exactly the same problem. Okay, so what they want you to do is, I'm just going to skip over this because it's actually a little bit confusing when you read it. So this is the number of binary digits that they want you to print. Okay, so in the case of one binary digit, how many ways are there to print binary in one digit? Well, it's either 0 or 1, right? And everyone knows that, right? So that's like the base case for this. Then count binary 2. If you have two binary digits, how many ways are there to count in binary? Well, you've got 0, 0, 0, 1, 1, 0, and 1, 1. For 3 digits, you should start noticing something. Okay, the 0, 1 here is the right column of this here. And the left column is, it's also 0 and 1, but it's twice as many items. And then for the third digit, now notice the 0 and 1, it's still for the left column, but there's again twice as many zeros and twice as many ones. At each stage, what you're doing is you're taking the output of the previous step, okay, and then you're adding new steps for the 0 and the 1. So how is this separate from traveling northeast? Well, it's the exact same problem for traveling northeast. Remember, for traveling northeast, if we want to start at 0, 0, and we want to end at 2, 3, how many ways are there to get there? Well, you start by either going north or east. Then from that north, you can go north or you can go east. See, same thing. You can either go north or you can go east. For the second step, you can either go from that 0, so that was the north, and then you can go north or east. Okay, if you went east, you now have the choice of going north or east from there. And then for the third step, you can choose that if you went north and north, which should be here and here, you could go north a third time. Or you could go east, see, north, northeast. Or you could have gone north, east, and then north again. So it's actually the exact same problem. All right, let's take a look at some code. So I'm not going to give you the code to do this, but I'm going to show you how we can use the traveling northeast problem and generate the same kind of output and what you need to do. So here I've got Eclipse. I've got it set up here. I've created a count northeast problem, and I'm passing in a number of steps here. So this method is going to print all possible paths traveling northeast within a given number of steps. So I've started listing out this example here for 3 steps, and I've done the first half of it, but I wanted to show you this is exactly the same as the binary here, except that instead of zeros we got north, instead of ones we got east. And I'm going to show you how to fill in the rest of this chart so that you again understand it a little bit better. So the first step here is we've done all the steps north there. In this case, we've done all the east steps. So we have to fill in what's the rest of this. Well, we could go, it doesn't really matter what order we do it in, but just to be consistent, I'm going to say that we're going to do the exact same way. We're going to prefer going north first. So if we go east, we could go north, or we could go east. That's my second step. For my third step, I can go either north or east, or north or east. And again, if I bring in that image here, you'll see that it's again the exact same thing as the binary. Okay, so it's just basically trying to make you iterate all the possibilities with 2 possibilities of your choices at each point. All right, so let's get to the code. So you may remember that for traveling northeast, instead of the more typical simple problem where you count down, so having steps and you count down until you get to 0 steps, what we're going to do is we're going to kind of work forward in the problem. We're going to start with nothing, and then we're going to start adding things going forward, and we have to know when to stop. And the only way you can do that is if you have a helper. So I'm going to create a second version of this. And this helper will take those steps and also a string for what the result is. And so what is this function going to do? Well, we're going to have a base case, and we're going to have a recursive case. Whenever you do these recursive problems, I strongly recommend go ahead and start listing out what are your base cases, what are your recursive cases here. So as I said, we're progressing forward in this problem. We're going from a single digit string, the first for the count of steps of 1. Here I can do for 1 step, print would be either north or east. For 2 steps, the print would be north and then north, or north and east, or east and north and east and east. All right. Now the base case, we need to know when to stop. So ideally I could maybe, I could pass in like 2 arguments here with a goal and the current step. But there's another way we can do it more simply, and that is we can count down. So we can start with, in this case, I was calling it with 5. Well, let's make it 3 since we know what the result's supposed to be. Let's call it for 3. And then we'll count down. Or even better, here, let's show you what the base case really is. Let's count for 1 step, right? So for the base case is when you've actually got no steps left. We're going to start with 1 though, so the base case has got to be 0. So if steps is equal to 0, that's really the base case. Then what do we want to do? We want to sys out, and for the case of 0, we're going to have a string with 1 element in it. So we're just going to print that. All right, but the case that we're initially calling with the value of 1, what we need to do is generate n and e, right? Those are the 2 possible cases. So we're going to call recurse in the north direction and recurse in the east direction. And what do we have to do the result? We need to add e there and n there. So we're going to call count northeast with steps. In this case, we have to decrement because we eventually, if we don't decrement, we're never going to get to our base case of 0. So, and for the initial step 1, it'll get to 0 in the next round. Steps minus 1, and then result appended with n. And then the other case is we're going to do E. So let's just run this here. Actually, let's go ahead and debug it. So we're going to call count northeast with 1. We're going to step down in here. Oh, I almost forgot. Need to actually call count northeast with steps and then the initial null string. Another problem I've got here is that I'm printing this result and then I'm falling through into the recursive case. So there are a couple ways to solve this. I actually prefer, when I'm done here, just to call return. Some people don't like that. The UW doesn't like that. So the alternative is to have a else, or sometimes an else if, and then close that there, and then what happens is you fall through to the end of the function. These are actually exactly identical to the compiler. It's just to me, it's clearer to actually put return there than having to fall through and not do anything. But either way, this works. So let's go ahead and debug this. set a breakpoint right here. Go into debugging. So it's not gonna, the steps is gonna be 1, and the result is initially null. So we're gonna step in, and now the steps should be 0. And so we're gonna print the result, and the result is passed in with n. And then the next time around, so we popped up a level. We just did this recursive call. Now we're gonna make this recursive call. So this is going to step in, and now the result is E. So it's going to print it, and then that'll be done. So we printed N or E. Now let's try it with 2. Go into debugging. So steps in this case is going to be, here, I'll just bring up the variables. Okay, so steps is 2. And the result is nothing. So it's going to jump in here. Now the result is n. So now it's going to do nn. So we are now 2 levels in, and the steps is 0. The result is nn, so it's going to return that. Then we popped up to a second level, so the result is n, and we're about to make ne. And it'll print that out. That's the final level. En, okay, and then this is going to be EE. Phew, okay, so that was EN and EN and EE. Okay, so for 3, I don't think I'm going to debug it because there's too many different options. We're going to be here a while. Click Run. And let me scroll this up a little bit. And we can see, compared to what I was expecting, yes, it's exactly what I was expecting. So this problem, count northeast, is exactly the same problem as the count binary. You just have to translate between the two. But it's the same concepts involved, that at each step you need to recurse through the different options. That's a very common theme in recursion. So you may have 1 option, you may have 2 options, you may have 3 options, you may have n options. I actually give my students an assignment where at each step you have n options, not just 1 or 2. And you need to recurse through all of those different options, okay? And then you have a base case otherwise. So that's how you do, let me switch back. Exercise 12.19 count binary. It's basically the exact same problem as traveling northeast. So if you've found this useful, please like and subscribe.